Christian, the team leader of our Arduino project, and I'm excited to introduce the team that made this possible. First, we have Christian, our programmer. He focused on writing the Arduino code to make sure all the parts and functions work properly. Next is Rizel, our analyst, who helped us understand what the project needed and guided us with the right planning and data. Then there's is Yesha and me were the designers of the group. We worked together to build the actual setup, connecting the components, arranging the parts, and making sure everything was working as planned. And together, we are Astriora, committed to excellence and collaboration. Thank you.
Arduino project number 14. This project uses an infrared IR remote and receiver with Arduino to switch a light on or off. It showcases wireless control and is similar to how household remote controlled appliances work.
In this project, we shall discuss and enumerate the list of materials required for our project number 14. First is the Arduino board, microcontroller that processes IR signals to control the LED, prototyping shield used for easy assembly and wiring, male-to-male jumper wires, connects IR receiver, LED, and resistor to the board. Resistor protects the LED from high current. 5 mm LED, the light that is turned on or off via infrared signals. And the last one, IR receiver diode, receives the IR signals from a remote control. And that's all we need for our project number 14. So let's get to the exciting part.
Hi everyone! Welcome back to another tutorial. Today's project is called Infrared Controlled Light. Before we start, here are the material we'll be using. Arduino board, breadboard, jumper cables, male-to-male, 5 mm LED, 220 ohm resistor, IR receiver, and the last one is our remote control. Alright, let's start assembling. First, place the Arduino board on your workspace so it's ready for wiring. Now, take one 220 ohm resistor and insert it into the breadboard. Once that in place, add the 5 mm LED right next to it. Make sure the LED's longer leg is connected in line with the resistor, since that will be the positive side. Next, let's add the jumper cables. For the first cable, connect from the breadboard to the ground pin on the Arduino. For the second cable, connect from the breadboard to pin 10 of the Arduino. This will complete the basic LED circuit. Now, let's place the IR receiver. Insert it on the lower left side of the breadboard, just like this. Then, we'll connect 3 more jumper cables. The third cable goes from the breadboard to the 5 volts pin of the Arduino. The fourth cable goes from the breadboard to the ground pin of the Arduino. And the fifth cable goes from the breadboard to pin 11 of the Arduino. Double check all connections. The LED is connected with a resistor. The IR receiver is wired to 5 volts, ground, and pin 11. And the jumper cables are properly linked to the Arduino board. And that's it. We've just finished assembling our infrared controlled light project. In the next tutorial, we'll upload the code that let us control this LED using the remote control. See you!
Hi guys, so this is our source code for AP number 14. First, this line includes the IR remote library so the Arduino can understand signal from an IR remote control. Creates a variable name remote pin and assign in the value 11. This tells the program that the IR receiver is connected to pin 11 of the Arduino. creates a variable named LED pin and assign it the value 10. This tells the program that the LED is connected to pin 10 of the Arduino. Declares an array of type unsigned long called codes with 10 elements. This will hold the IR code for the remote button 0 through 9. First element of the array, this hexadecimal number is the IR code for the 0 button. Second element of the array, this is the IR code for the 1 button. Third element of the array, this is the IR code for the 2 button. Fourth element of the array, this is the IR code for the 3 button. Fifth element of the array, this is the IR code for the 4 button. Sixth element of the array, this is the IR code for the 5 button. Seventh element of the array, this is the IR code for 6 button. Eighth element of the array, this is the IR code for the 7 button. Ninth element of the array, this is the IR code for the 8 button. And then the last 10 element of the array, this is the IR code for the 9 button. This starts the setup function. This runs only once when the Arduino is powered on or reset. Start serial communication at a speed of 96 bits per second. This allows the Arduino to send text messages to the serial monitor for debugging. Starts the IR receiver on the pin defined by remote pin number 11. The second parameter, enable LED feedback, picks the onboard Arduino LED link when a signal is detected. Sets pin 10, the LED pin, as an output pin so the Arduino can turn the LED on or off. Start the loop function. This runs repeatedly forever after setup function finishes. Check if the IR receiver has captured a signal. If true, the code inside the if block will run. Reads the raw I as signal data and stores in the variable value. Starts a for loop that goes from I equals to 0 up to I equals to 9. This is used to check each of the 10 stored codes in the array. Compares the received IR code with one of the stored code. If they match, it means the button I on the remote was pressed. Turns the LED on. Keeps the LED on for 500 milliseconds or half a second. Turns the LED off after the delay. Tells the IR received to get ready for the next signal. Without this, it would only read one signal and then stop. The code waits for IR signal if a valid button 0 to 9 is pressed. The LED blink on for half a second. The press button number is displayed in the serial monitor. That's all. Thank you.